In section 6, we look at a very popular or well-known design methodology that is popular in web applications. Most frameworks that support developing web applications are based on the model view controller design pattern. In this case, we have two components: the model, which manages the data and the behavior of the applications. So the model processes events sent by the controller, and the model has no information about the views and controllers. In other words, the model responds to requests for information about its state and responds to the instructions to change state as well. Right, the view it basically prepares the interface which is shown to the user. The users interact with the application through views, and these views represent information that the model or controller tells the view to present to the user and to handle user requests and sends them to the controller. The controller, of course, is like a go-between the model and the view. It glues the two of them. So it processes user requests and updates the model when the user manipulates the view, and the controller also updates the view when the model changes. Right. So there is some kind of separation of concerns. The MVC separates data, logic, and interface. This improves maintainability and allows reuse of code, which are the key principles that we found in service-oriented architecture and in the cloud component model. Right, now let's look at another development part methodology. This is RESTful web services. Where the word REST simply means representational state transfer. It is a set of architectural principles by which you can design web services and also web APIs that focus on systems resources and how resource states are addressed and transferred. So it has got some architecture component which apply to components, to connectors, to data elements within a distributed hypermedia system. Of course, what is important to note about RESTful web services is that they use a web API which is based on HTTP. Most of you guys have done networking course that also use the HTTP protocol, and of course in that in the diagram to the right you see that the web API simply uses get, post, put, and delete methods, and those are basically what are used by the cloud. So typically you have a client which sends a request, and the request is either sent by either put, get, and so on, and then the server sends a response. And a response, when it's received, it can be transmitted in a format like the JSON format. Now, as when we defined RESTful web services, we said that there are architectural constraints, and here is a summary of 6 of these constraints. The first constraint is, of course, that the RESTful web services they are forced to follow the client-server paradigm. Yeah, so there is, of course, a clear separation between the client and the server. Also, it's stateless. Requests are self-contained and cannot consume stored context on server, and session state stored entirely on the client. Another constraint is cacheable. Data in a response to request must be implicitly or explicitly labeled as cacheable or non-cacheable. In other words, clients can reuse cacheable data. Right. Then it's also a layered system. Each layer cannot see beyond the immediate layer with which they are interacting. This is the reason why, of course, you can't check security issues in the other layer. So it's a disadvantage in a way. Then uniform interface as well. You have method of communication between client server must be uniform. It must use UOU, universal resource identifiers, to identify requests. Also, you have what might be called code on demand. Servers can provide executable code or scripts to clients to execute in their own contexts. It's, of course, an optional constraint. It is an optional constraint and the only one. The rest are probably given with that architecture. You can't run away from them. You have to provide for them. You have to put up with those constraints. Right. This diagram illustrates clearly some of the characteristics that can be changed except the code on demand. Like layered systems, a server, you can't, uniform interface, post, get, put, and that's fixed, and cacheable as well. So that concludes this RESTful interface. In Internet of Things, of course, RESTful APIs are important, and therefore this RESTful interface approach is the one that probably would be most suitable for Internet of Things. In fact, when you guys were playing around with MQTT, we were in a way combining. Within the MQTT, there's an implicit inclusion of REST. Remember the topics? Those topics looked like a URI. Yeah, this look like RESTful services. Each topic looks like a RESTful service, but embedded within the publish and subscribe mechanism.